Good day. So what I shall do today with you is question 18.4, which is the homework question on the risk of a portfolio. And this is a follow-on from the previous two lectures on the risk of a portfolio. So let's move ahead then. If you would like to consult on this material and material that we've covered in the last two lectures in Learning Area 8, and also for leasing, you are most welcome to contact me via email, and I'm also available for telephonic conversations between 10 and 12 on Wednesdays. And my phone number is included there below for your reference. So to start off, let's look at the information that we've been given for this question. So you are told that you have been given the expected return data on three assets. Asset F, G, H over the period between 2014 and 2017. So here we see the period that we are dealing with. Here we have asset F and the corresponding expected returns. Here we have asset G and the corresponding expected returns, and also asset H and the corresponding returns. Using these assets, you have isolated the three investment alternatives shown in the following table. And here what we have is the investment alternatives. So alternative 1, you invest 100% of your funds into asset F. Alternative 2, you invest 50% of your funds into asset F and 50% of your funds into asset G. And then alternative 3, you invest 50% of your assets, of your funds into asset F and 50% of your funds into asset H. So that is the information that we are given. Let's see what's next then. So what does this question require us to do? Well, first of all, what we need to do is we need to calculate the expected return over the 4-year period for each of the three alternatives. Then what we need to do is in B, calculate the standard deviation of returns over the 4-year period for each of the three alternatives. Then in C, use your findings in parts A and B, so those are the two parts above, or the two parts of the question above, to calculate the coefficient of variation for each of the three alternatives. On the basis of your findings, and that's the final part, which of the three investment alternatives do you recommend? So what we shall do is we shall start with A. So what we're going to do is we're going to start with asset F, and what we've been told is that 100% of our funds are invested in asset F according to alternative 1. If you recall that the formula for the return on a portfolio is the sum of the weighted returns of the constituents. Now what we have is we have only one constituent in this portfolio, and that constituent is asset F. Okay, in other words, our W is equal to 1, and what that means is that we can essentially ignore it. Okay, that is because our W is 1, which represents 100% of our investment in asset F. This obviously is not the case when you have a split or you have more than one constituent, such as asset G and H in the portfolio. So what we do is we sum up the returns over each year. So as you can see, you have 16% here, which corresponds to 2014. You have 17%, which corresponds to 2015. Then you have 18%, which corresponds to 2016. And finally, 19%, which corresponds to 2017. And what you do is you divide that by the number of periods that we have in our question, which is 4, and hence that is why the number 4 is reflected there. What you will find is that the sum of those is 70, and you divide that by 4, and you find that the return on asset F over this time happens to be 17.5% on average. That's our expected return. So that is so much for the first alternative that we have. Now what we need to do is we need to look at the next two alternatives. So our second alternative is that our funds are invested in F and G in the portfolio. So we now have a portfolio comprising of assets F and G. And we are told that 50% of the funds are invested in asset F, and the other 50% of the portfolio comprises of or consists of asset G. So our weights are 0.5 on asset F, and the other weight is 0.5 on asset G. And again, we have our formula here for the returns on a portfolio. And note now what we need to do is we need to take into consideration of these weights, okay? Because these weights differ according to the constituents of the portfolio. Okay, so let's do the workings. So in the first step, what we do is we calculate the expected returns on a portfolio comprising of 50% of asset F and 50% of asset G. So here you have the returns in each year. So for example, that 16% corresponds to 2014, and the 17% corresponds to 2017, the 18% to 2016, and the 19% to 2017. And these are the returns for an asset F, and the same can be said about asset G. However, what is worth noting is that now we multiply the return in each year for asset F and asset G by 0.5, because we are told that for the second alternative, 50% of the portfolio consists of asset F, and 50% of the portfolio will also consist of asset G. Okay, so this is just a multiplication now of the returns in each year by 0.5, which stands for 50%. And now we find the portfolio return for each individual year, which is 16.5%. This is not really that surprising, because as F increases, as the returns on asset F increase, the returns on asset G decrease. So essentially the increase in asset F is offset by the decrease in asset G. And we have a return of 16.5% in each year. Now to calculate the expected portfolio return over this period, you just simply sum up the value of the return in each year, which is 16.5%, and divide that by 4, where that 4 represents the number of periods that we have been looking at. And you find that the expected return on a portfolio consisting of 50% of asset F and 50% of asset G is 16.5. Okay, so that is quite an important number, because we'll be using that to calculate our standard deviation. So that is how we calculate the expected returns for a portfolio comprising of 50% of asset F and 50% of asset G, which is alternative 2. So now we turn to our final alternative, which is alternative 3. And alternative 3 comprises of asset F and asset H, whereby 50% of our portfolio is in asset F and 50% of our portfolio is in asset H. So again, this is a multiplication, a summation that we are dealing with here. So it's in 2014, it's 15% or 50% of our return on asset F, which is 16% in 2014, 50% of our return on asset F in 2015, and so on for 2016 and 2017. And the same holds for asset H. So we calculate, or we multiply 14, which is return on asset H in 2014, by 0.5, which represents the weighting of this asset in our portfolio. And summing these values, that 8.0 and 7% for asset H in 2014, we get a portfolio return of 15%. We do the same for all the other years, and as you can see, moving downwards, we have the portfolio return for each of the years. Okay, so those are the returns you get in each year for portfolios that comprise half of asset F and half of asset H. To find the expected value of return, okay, so the expected returns, it is a summation of the returns on the portfolio as opposed to the individual stocks in each year. So for example, 15% in 2014, 16% in 2015, 17% in 2016, and finally 18% in 2017. Then what we do is we divide that by 4, because that is the number of periods that we are dealing with, and we find that the expected return for that period is 16%. Okay. So the expected return is the same as for our portfolio on the previous slide. Okay, so now what we have done is we've calculated the expected returns on each portfolio. So now what we need to do is the second part of the question requires us to calculate the standard deviation. And that will be the standard deviation in a portfolio consisting of only asset F and the standard deviation of a portfolio comprising of half of asset F and half of asset G. And then finally our third portfolio, which is half of asset F and half of asset H. And what I have done here is, to make it easier for you, is stated the returns that we have on the portfolio FG and portfolio FH. And just as a summary, our expected returns are stated here. So our expected returns on portfolio comprising of only asset F is 17.5. Our expected return on a portfolio comprising only of asset F and G is 16.5, and for F and H it is 16.5. So if you recall, the standard deviation formula is as follows, and that is the sum of the differences between the actual observed returns and our expected returns, as represented by R bar, and here we have these expected returns. So let's do the workings. So what we're going to do is we're going to start with alternative 1, whereas you see the returns here for asset F, so that's 100% of funds being invested in asset F. And here is our standard deviation formula for your reference, and apologies that it is to the side, but I'm a little bit limited on space on this slide in terms of the workings. So first part, it is the difference between the observed returns. Okay, so these are the returns that we see for each year. So for example, in 2014, that is 16%. So that represents this part here where I am making this little cross. That is the 16% less the expected value. Okay, on the previous slide, the expected value of returns, okay, the expected returns of this period happen to be 17.5. Okay, so that is inserted there. Okay, that 17.5 is the expected return, which is the R bar, and that is then squared. It's squared so that we have absolute values that are not negative. And you do that for each year. So here you see 17%, and that corresponds to 2015, 18%, which corresponds to 2016, and 19% finally, which corresponds to 2017. So that's the return in 2007. Okay, so now it is 4 minus 1, and that is what we divide our top term, our numerator, and here is our denominator. So then here are the workings. So here's a summary of the workings. So that is the next step. And finally, what we have is yet another summary of the workings, and we find that our standard deviation happens to be 1.291%. Okay, remember that in order to find this value, you need to square root this part here. Okay, so this is the square root, this thing here. Okay, so now what we find is that the standard deviation on asset F, or more specifically a portfolio comprising only of asset F, they are essentially the same thing because it is the only asset in the portfolio, is 1.291%. So now let's find the standard deviation for a portfolio comprising of FG. So that is on the next slide. So now what we're going to do is we're going to calculate the standard deviation for alternative 2. So I have again the standard deviation formula here. And let's start with the workings. So in this instance, again, we take the actual returns that we observe, which are 16.5 in each year for F and G, and we subtract from that our expected return, which is 16.5 on this portfolio, and we do that for every year. So note, what is it that you are expecting here? What is the expected outcome? Well, the expected outcome is that the standard deviation will be 0. And why is that the case? Well, that is because our observations don't deviate from our expected outcome. Okay, so hence there is essentially no risk. What happens, what we see, is indeed what we expect to happen. In each year, our return is 16.5, the expected value of returns is, or expected returns for this portfolio are 16.5%. So what that essentially means is that there is no divergence from the expected outcome, and hence there is no risk. Our standard deviation is 0. So now finally, let's do the workings for alternative 3. So the first part is again applying our standard deviation formula, which we have here, and that is the returns we find on the portfolio in each year. So for example, that 15% is what we find in 2014, less the expected return, which is 16.5% on this portfolio. Same goes for 2015, which is 16%. Less the expected return. Same for 2016, which is 17%, less the expected return. Then for 2017, it is 18, less the expected return of 16.5. And you work through that and you find that the standard deviation for portfolio FH is 1.291%. Okay, so let's summarize that on the next slide. So let's quickly summarize our findings before we proceed on to part C. Okay, so our expected returns are stated here. For a portfolio comprising only of asset F, it is 17.5%. For a portfolio comprising of assets F and G, it is 16.5%. And finally, for a portfolio comprising of assets F and H, it is 16.5% also. Okay, so here are expected returns on the portfolios. The corresponding standard deviations are as follows. So it's 1.291% of a portfolio comprising only of asset F, 0 for a portfolio comprising of asset F and G, and finally also 1.291% for a portfolio comprising of assets F and H. Now in the final part, well, sorry, not the final part yet, in part C, we are requested to find the coefficient of variation, and here is the formula for the coefficient of variation. So I think it needs a slight explanation. So what is the coefficient of variation telling you? It's telling you how much risk you take on per unit of returns. Okay, so how much risk are you carrying on in order to get 1 unit of returns? Obviously you want to carry less risk in order to achieve 1 unit of returns, or 1% of returns. Sorry, maybe I should use 1%. It's the amount of risk in terms of standard deviation per 1% of return that is carried by you. Now what we do is we use these inputs to calculate our coefficient of variation for a portfolio consisting of only asset F, and then for a portfolio with assets FG, and a portfolio with assets F and H. And what you find is that the coefficient of variation is lowest. It is 0 for the portfolio consisting of asset F and G. And why is that? What does this mean? This means that you are not taking on any risk in order to earn 1 unit of returns. Okay, so no risk is borne. Okay, no risk is borne at all in achieving that 16.5%. So that is the interpretation there. So then let's move to the final part and see how this actually applies. Okay, what do we do with these coefficients of variation, or this coefficient of variation? So now what we're going to do is we're going to answer which investment should be chosen and why. So this is part D, and I've stated the question in a very summarized form. So which investment do we want to choose and why? And what we do is we use the coefficient of variation. So what we do is we choose alternative 2. Okay, we go for the investment that has the lowest coefficient of variation. Okay, so you take on the least amount of risk, specifically no risk, in order to achieve that 16.5%. So since there's no risk, you will achieve that 16.5%. There will be no deviations from that. There will be no divergence from it. So alternative 2 is the best because it has the lowest coefficient of variation. Okay, now why exactly is that the case? Well, what we need to do is we need to go back to the beginning. And as you recall in the past 2 lectures that I've done with you, we discussed the concept of diversification, and correlation came into it. Now, if you look at it this way, if you look at it in terms of correlation and how correlation reduces risk through diversification when assets are correlated in different ways. Let's start with asset F. All that happens is that asset F, the returns on asset F increase. However, what happens is that when you combine F and G, as the returns on asset F increase, the returns on asset G decrease. In other words, there is an offset in variation. Okay? So you're offsetting the variability and you are achieving the expected return as a result. So although F increases, the returns on asset G decrease, offsetting any increases in asset F, and therefore any deviations from the expected return. Okay? So you're seeing the maximum benefits of diversification. And as the two are moving in opposite directions, what this implies is that they are negatively correlated. On the other hand, what is it that happens that if you combine F and H? Okay, as the returns on F increase, so they go from 16% to 19%, the returns on asset H increase from 14% to 17%. So what you are seeing here is you are seeing positive correlation. Okay, so hence there is no offsetting effect. There's no offset in terms of the variability being offset. So hence what happens is that we deviate from our expected returns, unlike in the instance of asset F and G. So hence portfolio F and G is best, or the portfolio comprising of assets F and G, because it is diversified and hence it has the lowest level of risk, and yet it yields you a return of 16.5. You do not need to take on risk in order to achieve that return. Okay, thank you. That is the lecture for today. The exercise for today. You can email me, or you are welcome to call me and for consultations. I look forward to hearing from you, and please feel free to do so if you have any questions. My details are on the second slide. Thank you.